8-1, day 1, day 2, last week. Then we had 8-2, 8-3, and then you'll have your application problems, those 5 problems that we just talked about, okay? We don't have a review day. Tomorrow is the quiz. So probably what we'll do tomorrow is we'll review at the beginning of the hour, probably maybe 15 minutes or so, kind of going over everything. And then we'll take our quiz, just so you have plenty of time to get through it. As always, if you ever want to come in before school, during crew, after school, whatever, I'm here. If you want to come in and kind of go over some of the stuff, if some of the stuff is not making sense to you or whatever, or obviously you can come in and do corrections on your test from last week. Those are in the grade book now. So if you want to try to improve your test score, you'll have until next week to do that, because next week we're looking at Chapter 8 test. I don't remember what day, but next week we're looking at Chapter 8 test. So you got about another week to get your Chapter 7 test retaken if you want to. All right, I'm going to skip over the problem at the top, the warm-up. We're going to move right into side similarity. Yesterday we only had one. We had angle similarity. We had to have 2 angles that were congruent in order to be able to prove that the 2 triangles were similar. And all of these theorems only work for triangles. Early on in 8-1, we were looking at other figures like quadrilaterals and parallelograms and maybe even a pentagon or a hexagon. But yesterday and then again today, we're only looking at triangles. That's the only triangle, that's the only type of figure we can use when we're using these theorems. So we're going to have a couple of different theorems today. The first one is side. And as I look at these 2 triangles, once again, we're talking about, as I compare these 2 triangles, are these 2 triangles the same size? Okay, just by looking at it. ABC and RST, are they the same size? No. So that tells me they are not congruent. So we don't want to say that they're congruent, okay? This is different than what we did at the beginning of the year and first semester. We're not proving that these 2 triangles are congruent. We're proving that they are similar. And so the word that we're looking for here is they have to be proportional, okay? And if I'm going to do side, the sides are not congruent. The sides are proportional, okay? So what we're looking at here is that AB matches with RS, BC matches with ST, CA matches with TR. All of those have to be in the same ratio to one another. Whether it's 2 times bigger, 3 times bigger, it doesn't even have to be a nice whole number, okay? Maybe the scale factor is like 4/3, but they all have to be reduced to be the same thing. If they all reduce to be the same ratio, then we would say that they're all proportional. The one thing that's different about yesterday is on this one, we don't have to know any angles. All we have to know is all 3 sides. If all 3 sides are proportional, then we have 2 similar triangles. We don't have to know any angles, okay? So yesterday was all angles. For this first one today, it's all sides. All we care about is the sides. Okay, so let's look at, it said try to determine is DEF or GHG similar to ABC. So let's start with the first 2, okay? We're trying to compare it to ABC. So let's pretend like this one isn't even here for right now. Let's compare ABC to DEF. Now here's the part where we want to go. I'm going to start with the biggest side over here, which is 16. And the reason I do that, you could also start with the smallest side, which would be fine. But I want to compare the biggest side here to the biggest side here, which is 12. Don't look at how the picture is drawn. Compare big to big, okay? And then we're going to go medium. So on this one, 12 is the medium size. Over here, 9 is the medium size. We don't know if they're equal yet, but we want to see if they're going to be equal. So I'm going to go ahead and put equal in there because we want to know, are they equal? And then finally, short side would be 8 to 6. Okay, so have some kind of a pattern that you go to. Whether you start with the smallest side or you start with the biggest side, we got to go big to big, medium to medium, small to small. or you can start with small if you want to. We're going to reduce all of those, okay? So let's do one at a time here. What's something that goes into both 16 and 12? 4, okay? Always take out the biggest thing. Like you might say 2. 2 definitely goes in there, but 2 is not the biggest thing, okay? So we're going to take out 4. If I take 4 out of 16 and 12, that gets me 4 over 3. Okay, then we're going to do 12 over 9. Out of 12 and 9, what GCF can I take out? 3. So I'm going to take 3 out. And finally, 8 over 6, what can I take out? 2. So we would say, yes, these are all the same. Okay. Now, if I was going to write a similarity statement here, the first triangle, you can do it however you want to. Okay? A lot of times you might go alphabetically. And so we could go ABC. Okay? Is it wrong to call it CBA or BAC or anything else? No. You can call the first triangle anything you want to, but typically we probably would go alphabetically. But then, as we've talked about the last couple of days, we have to match up what goes with what. Okay? Now, another reason why I chose ABC is because I'm going around this triangle from starting with the smallest side, so I'm going small, medium, large. So I'm starting with the smallest side to the middle side to the longest side. Over here, the shortest side is 6. So we're going 6 to 9 and then to 12. So the order around this triangle would be D, E, F. It may not always be alphabetical. So don't just assume that, oh, because ABC is alphabetical, that DEF would be alphabetical. In this case, yes, it is, but it may not always be that case. Okay? Now, let's compare this one to this one. So let's eliminate the middle one, okay? We're going to compare ABC to J, H, and G. So once again, the biggest side over here is 16. Biggest side over here is 16. Medium size is 12. Over here is 10. And here's what I'm going to tell you. Do I even need to compare the third side? What does 16 over 16 reduce to be? 1. Does 12 over 10 make 1? No, it's a little bit bigger than 1. In order for this to be 1, it would have to be 12 over 12 or 10 over 10. Okay? So these two are not going to reduce. I don't even care what the third one is. Okay? And it might be the same as one of those others, but these two are not equal. They're not a proportion. They're not equal to each other. So these two are not similar. Okay? All three sides have to be in the same ratio to one another to make it work. It's a little bit of work here because we have 3 triangles that are given to us. And we're trying to figure out, are they relational? Are they similar to one another? And so really it doesn't matter which one we start with. We could compare LMN to RST. We can compare LMN to XYZ. We just got to find some that match up, okay? And really we probably should check all 3 parts. We're going to go this one to this one, this one to this one, and maybe even these 2 as well. Okay, so let's do the first 2. Let's compare LMN to RST. Biggest side on LMN is 26. Biggest side on RST is 33. Medium size is 24 over 30. Okay, and I could go ahead and do the third side as well. But here's what I'm going to talk about 26 over 33. Does 26 over 33 reduce? Is there any numbers that go into both 26 and 33? No, because the only thing that goes into 26 is 2. 2 times 13. There's no other numbers that go in here. Okay? So if I reduce this, it definitely is not going to give me this. Okay? And plus, I can't reduce 26 over 33 because 2 doesn't go into 33. So these two are not going to be equal. So I would just look at those first two. Can I simplify it or not? Okay? And if I can't, if they're not equal, I'm moving on to the next one. So let's go LMN to XYZ. Okay, once again, big side is 26. Big side over here is 39. Okay, and then we're going to have medium-sized, which is 24 over 36. And then finally, smallest side is 20, and it matches with 30. Okay, in your calculators, and this is going to be helpful to you today as well, is in your calculator, there's two ways that you can do this. Most of your calculators have a fraction button that if you hit 26 fraction 39, it reduces it, it gives you the reduced form. Especially if you don't know if there's something that goes into 26 and 39. It may not just pop right out at you. Okay, so if I reduce 26 over 39, what's it going to reduce to be? 2 over 3. Okay, what about 24 over 36? 2 over 3. What about 20 over 30? 2 over 3. All of these are 2 over 3. So I would say yes. These two are similar. Okay? If you don't know where that fraction button's at on your calculator or how to use it, let me know, and I can help you with that. Okay? I think you're going to have some on big ideas today that are going to be decimals. You can't put decimals in a fraction. So if this happened to be like a decimal right here, I would take the decimal divided by whatever this number is down here and see what it gives me. Okay? And then change it to a fraction. We want to leave our answer as a ratio. That's our scale factor. All right. Which of these three triangles are similar? So we're going to say triangle LMN is similar to, and once again, notice I went small, medium, large. I started with the smallest. 20 is the smallest, the middle size, and then the biggest. Over here, 30 is the smallest. And then I would go to 36, and then I would go to 39. So I would go Y, Z, X. So as I said before, it may not be alphabetical. Y, Z, X is not in alphabetical order. We're not looking for alphabetical order. We're looking for the correct order of the letters that give me the right ones, okay? So like LM has to match with YZ. 20 has to match with 30, which it does, okay? So we got to make, I stress it because the order that we put those letters in is all the difference in the world, okay? If I put these in some order, you're comparing two sides that are not the same sides together, okay? So you got to be extremely, extremely careful about that. Okay, on example 2, they already tell me that these two are similar. Okay, we already know that because it tells me that. So we're going to use that information, and based on the side similarity theorem, because these are similar, all the sides are in the same proportion to one another. So the first thing that I want to start with is I want to use two sides that I know both lengths to. I don't want to use the side that has an X in it, right? Because I don't know what that side length is. So like, let's say AB. AB is the first two letters here. It's going to match with DE. DE is 12. Those are the two sides that match up. They may not be left and left like they are here. So don't just assume, oh, because this is on the left, this is on the left. Maybe 4 would match with 18 in some cases, okay? But in this case, 4 matches with 12, which is 1 over 3. Okay, that's our scale factor. That's what we're going to use. It doesn't have any x values in it. So we do not want to use something that has an x value in it. So we got to find two sides that match up where we don't have a variable. So we're going to start off using that scale factor, 1 to 3. We're trying to find the value of x. Okay? And if I had to choose, would I rather use BC or would I rather use DF? Because both of those have x's in them. Which, okay, how come? Yeah, don't have to distribute, absolutely. Okay? So this would be a little bit easier to use. It's not wrong to use this one down here. It would be okay, but there'd be a little bit more work involved because you'd have to distribute. Okay? So why not try to make it as easy on us as possible, right? That's the goal. So this is x minus 1. It's going to match with 18. So when I set up my proportion, which is what we've been doing for the last 2 or 3 days, x minus 1 matches to 18. Okay? And just make sure that like BC is the last 2 letters here, EF is the last 2 letters here, BC and EF do match. Okay? Make sure they match up. If those two aren't the ones that match up, then we can't set up a proportion like that. Hey, we haven't seen cross multiply with one like this yet. We saw this in Algebra 1, but I don't think we've seen it yet this year. When I have an x minus 1, this is extremely important, okay? When I have an x minus 1, or anything with a plus or minus in it, we want to put that x minus 1 in parentheses. Because when I cross multiply, I got to take 3 times that entire expression, which essentially means I'm going to have to distribute, okay? So even though we tried to not distribute, we're still going to end up having to distribute here. And then we're going to take 18 times 1, which is just 18. Okay, so we're taking 3 times this, 3 times x minus 1, 1 times 18, which we'll just write as 18. Now it's just a regular old equation. But if I don't put parentheses there, then I'm not going to get it written out correctly. So now we're going to go 3x minus 3 equals 18. We're going to add 3 to both sides. And we get x equals 7. Hey, whenever we solve equations, one thing that we've talked about all year long is make sure that it works, right? If I really wanted to make sure that this works and satisfies my sides, if I took 7 and plugged it in right here, 7 minus 1 would be 6. What if I reduce 6 over 18? What would 6 over 18 reduce to be? 1/3. Okay. And what did we say our ratio had to be? 1/3. Okay. So verify that it works. Now, some people aren't going to do that step. Okay. But if you're not sure if your answer makes sense, or if you just wanted to verify if it makes sense, you can always take that and plug it back in and make sure that it works. Okay. My question is, why wouldn't we check? Right. We have the ability to see if my answer works or not. Okay, on something like this, the reason why we got to really be careful about what we match up, just to show you why sometimes you may set something up and it may not work out very well. If I tried to match up AB to DE, I could say 16 over 2x. AB goes to DE. Okay, but if I then choose to go BC to EF, this is not going to be a whole lot of fun to solve. Because when I multiply these two together, I'm going to have to distribute this. I'm going to have to take 2x times x. And that's something we haven't done for a long, long time. Okay? So I don't really want to do this. Okay? So I would not set it up like this. It's going to be really hard to solve that one. So instead, as we said before, DF and AC match up. okay? And you can either go 9 over 12 or 12 over 9. I don't really care which order you go in, okay? It's going to work out the same way. As long as I go, like on this one, I'm going small to large, okay? I'm going left to right, however you want to think of it, whatever makes more sense to you. Probably would make the most sense to move left to right, since that's what we're used to doing. Okay, then I can either compare DE to AB, or I can compare EF to BC. So I'm going to use 2x to 16, or 6 to x plus 2. Does it really matter? Probably not, but the one I'm going to choose here, just to show you this, I'm going to use 2x to 16. Okay, this is different than one we did just before. This one doesn't have a plus or minus sign in it. It's just multiplication. So as I cross multiply here, I don't necessarily have to put that in parentheses, because what happens if I take 12 times 2x? 24x. No addition or subtraction. But we can multiply those together. Some people think they can't because one's got an x and one doesn't. That's only with addition and subtraction that we can't put those together. If it's multiplication, we can multiply them. Okay? What about 16 times 9? What's that give me? (16 times 9). 144. Okay. And then to finish this out, we're going to divide by 24. And 144 divided by 24 gives me 6. So there's some different options for your proportion that you're going to set up. But if you see a proportion that has multiple x's in it, like this one here, in a lot of cases that might be really kind of difficult to solve. So that's probably not the way I would choose to do it. Okay, yesterday we did angle-angle. Earlier today we did side-side-side. Here's the third one. So these are the 3 ways that we can prove that triangles are similar. This one is side-angle-side. Call it side-angle-side similarity. And it's just like we think about. We have to have 2 sides and an angle. The angle has to be what we call the included angle. And when it's the included angle, then I'm comparing XZ to PM, and I'm comparing XY to MN. Okay? So for instance, let me show you how this one would work. If I say this is 4 and, probably want to go the other direction. Let's say this is 4 and this is 2. Let's say this is 6, and let's say this is 3. Okay? So we're saying that this triangle is 2 times bigger than this triangle. 4 is 2 times bigger than 2. 6 is 2 times bigger than 3. Okay? Those are the 2 sides that we can compare. We know they're 2 times bigger. We don't know anything about the third side, so we only have 2 sides. The angle has to be between these 2 sides. So this angle and this angle are congruent. Angles have to be congruent, right? So we have side, angle, side, just like we did with congruency, but now it's for similarity, okay? But it has to be in that order. It has to form a side-angle-side relationship. The angle has to be between those 2 sides. That's the most important thing. Okay, coming down here. Building a lean-to shed or shelter. Can we construct the right end so it is similar to the left end using the angle measures and lengths as shown? Okay, so for the first triangle, this is 6, this is 10, my angle is 53. For the second triangle, we have 9, we have 15, and this is 53. So first of all, the angle is the same, and it's between the 2 sides, so that part's okay. All we got to verify now is, are the sides in the same relationship or ratio to one another, okay? So we're going to go 6 is to 9 as 10 is to 15. What does 6 over 9 reduce to be? Okay, 3 goes into both, right? So 2 over 3. What about 10 over 15? What goes into both? 5. And so 5 goes into 10, 5 goes into 15. Both of those are the same. Okay, so we would say, yes, we can construct this so the two sides are similar. We would say something like we have two pairs of, here's that word again, proportional sides and the included angle is congruent, 53 degrees. Okay. So if we asked you to explain, that would be kind of the way we would ask you to explain it. We proved that they're both proportional and we have a 53 degree. Okay, this one down here. Explain how these two triangles are similar. Okay, what angle are we going to use here? Which one? The 90, right? It's the only one we're given. I don't want to use any other angle because I don't know any other angle. 90 is the only angle we have. They both have a 90-degree angle, and they have two sides that touch that 90-degree angle. Okay? If I try to decide which side does 24 go to, it doesn't always have to be this one, but 24 is smaller than 28. 18 is smaller than 21, so 24 has to match to 18. Okay, on this one, I want to show you this because you can use this here. You can reduce it, okay, which we've been doing for a lot of these problems. Reduce both of them down, make sure they're both the same. Now, here's kind of an easier, quicker way in some cases that you could do this, especially if you only have two fractions like this. Cross multiply both of these. What does 24 times 21 give me? How much? 504? What about 18 times 28? 504. Okay? So that's how you could use cross multiply to determine if they're the same. If they're the same value, then we would say yes. And they have a 90-degree angle in between. If they're not exactly the same, then we would say no, they are not proportional. So you can either reduce them or you can just do a quick cross multiply to check it. Okay? Works either way. Kind of another quick way to do that. So we're going to say yes, these are similar because they have proportional sides, and we showed the proportional sides, and they have an included angle that is congruent, the 90-degree angle. Okay. But you would want to show some work here to show that they're, whether it's reducing them or do the cross multiplying, however you want to get there. All right, this last one, just real quick here. XZW, okay? XZW is this triangle right here. That's the first one that we're focused on. What I would recommend here, you really have three triangles here, okay? You got this one right here, which is on the left. You got this one right here, which is on the right. And then you got the big guy, right? Which is the whole thing. So really pay attention to which two they're asking us to look at. So here we're looking at XZW. We're looking at the one on the left, based on these three letters. That's the one that has XZW in it. So I'm going to redraw that one. You don't have to like draw it to scale or anything like that. Label it XZW. We got a 90-degree angle in there. I know it's 90 because it sits right next to another 90, right? My side lengths would be the ones that are already labeled, those three right there. Okay, the next triangle is YZX. YZX, okay? We're looking at the one that's on the right. Now what I like to do here is I like to draw it the same way the other one's drawn. I like to put the 90-degree angle down here on the bottom right, okay? that is where z is at. Okay, this side right here would be zy. And we know zy is 9. We know this side over here is xy. It would be 15. And then that makes this side down here 12. So I have two options here, okay? I can use either of the methods. First of all, we can't use angle because we don't know any other angles. So I can't use what we did yesterday. I know all three sides here. So what I could do is I could prove that all three sides are proportional to one another. So real quickly here, we could go 20 over 15. We could go 16 goes to 12, and we could go 12 goes to 9. All of those have to reduce to be the same thing. So you got to do a little bit of work here to prove that those all reduce to be the same. Would it be okay if I flipped these and put 15 over 20 instead? Yeah, okay. It doesn't matter if you go big to small, small to big. You got some options there. In this case here, all three of these become 4 over 3. So then I could say because of side, side, side. All three sides are in the same ratio to one another. If I did 2 of the sides, I would have to do 16 is to 12, as 12 is to 9. I have to use these two sides because the angle that we know is between those two sides. And so then I would also say we have a 90-degree angle. So we could also do side angle side. You don't have to do both. You'd have to do one or the other to show me why and how. Okay, but you could do either one. Kind of depends. What would be the easier way? I would say probably this would be a little bit easier, right? One less ratio you have to reduce. Okay, down here at the bottom, this gives you the 3 similarity theorems. So if you have a problem tomorrow on the quiz that says, why are these two triangles similar? You can use any of those 3 to prove it. But you got to make sure you understand how to do that with those 3, okay? So you might want to look over those tonight. That's why we put them all in one spot right there. 1 yesterday, 2 more today.